I thought this video is going to be quite long, so there might be a part 2 for this. So tonight's long video is about space and astronomical events in 2025, the highlights for this year. I will go for every month, and there will be a couple that you might have missed or you might have seen them. So, January. From January 1st to the 12th of January, you will see the quadrantid meteor shower. The year starts with a bang with the quadrantids, one of the strongest and most reliable yearly meteor showers. Active from December 28, 2024 until the 12th of January 2025, this shower is famous for its fireballs, exceptionally bright meteors. In 2025, they will peak on the night of 4th of January with a possible rate up to 120 meters per hour at the maximum. The waxing crescent moon might drown out a few of the fainter meteors on this night, though luckily it will set below the horizon just before 10 PM from the UK. To see this the shower bundle up nice and warm, find a dark location free from light pollution and veil your eyesight as much of the sky as possible. To work out if you've seen a meteor, trace it back to its radiant point, which should be in the northern part of the constellation Bootes. On the 4th of January, see Saturn hide behind the moon. An occultation in astronomy occurs when, from our vantage point on Earth, is one celestial object appears to pass in front of another. On January 4th, from the UK, we'll see a lunar occultation of Saturn, meaning Saturn will appear to have passed behind the moon, which will be nearing its first quarter phase. At around 5:15 PM, Saturn will be visible just about touching the northwest of the moon, and it will then disappear behind the shadowed portion of the moon. Around 6:30 PM, Saturn will reappear from behind the southeast of the lunar disk. Other regions won't see an occultation, but Saturn and the moon will appear close to each other in the night sky, known as a conjunction. On the 10th of January, Venus at greatest elongation east. Venus and Mercury are bright enough to be seen with the unaided eye, but because they're closer to the Sun than Earth is, they rarely get far from it in the sky. This makes them difficult or even dangerous to see at times. This is especially true for Mercury, which is smaller, fainter and closer to the Sun than Venus. If you'd like to see these rocky worlds for yourself, your best bet is usually to wait for their greatest elongation. This is the time when each planet is farthest from the Sun, and therefore more likely to still be above the horizon when the blinding sun has set. Venus will reach its greatest elongation east, and therefore seen in the evening, on the 10th of January, and its greatest elongation west, seen in the morning of the 1st of June of 2025. And the final one of January is Mars at its brightest. When a planet is at opposition, it's directly opposite to the Sun in the sky, which illuminates the planet's face so that it appears at its brightest. On January 16th, Mars will be at opposition, making this a great opportunity to set your eyes or telescopes on the beautiful red planet. February now. Late January and most of February, a gathering of planets. If you're a fan of gazing at the planets, set a reminder for after sunset on any evening from late January into February, where you'll have a great view of the 6 planets: Saturn, Venus, Neptune, Uranus, Jupiter and Mars, scattered across the sky in the hours after sunset. Between 18th of January and the 21st of January will be particularly good, as Saturn and Venus will be close to one another in the sky, slowly swapping places in the planetary parade. Saturn, Venus and Jupiter will be easily visible as the bright white points of light, and Mars is an orange dot, but Uranus is quite faint and will require very dark skies or a telescope to attempt to see it. Neptune, meanwhile, will require a fairly powerful telescope to observe. In the late February, Mercury will also join the parade, creating a total of 7 planets on display in the sky. However, by this point it will be much more difficult to see Saturn and Neptune, as they will be very low from the southeastern horizon after sunset. Search for another galaxy. February kicks off what is known as galaxy season from the northern hemisphere, where we have the best opportunity to look at these stunning distant cities of gases, dust and stars. A new moon on February 28th gives you a chance to escape the light pollution of the moon and get a good look at some galaxies. An ever-popular astronomy and astrophotography target is the Andromeda galaxy, one of our closest galactic neighbours at around 2.5 million light-years away. You'll find it near the Andromeda and Cassiopeia constellations. For the best chance of observing it, get somewhere reasonably dark to look at with a telescope, or especially dark to see it with a small pair of binoculars. Under very dark clear skies, you can sometimes even make out as a small smudge with the naked eye. March now. 8th of March. Mercury at greatest elongation. Mercury will reach its greatest elongation east, its farthest point from the Sun, for the first time in 2025 on March 8th. As it's in its eastern elongation, this will be the best seen in the evening. Mercury's greatest elongation east will happen again on 4th of July and October 29th, and it will reach its greatest elongation west, best seen in the morning, on April 21st, August 19th, and December 7th. As with any observation close to the Sun, make sure you don't look directly at the Sun, and if observing with a telescope or a pair of binoculars, wait until after sunset or before sunrise to avoid accidentally pointing them at it. From March 14th, a partial lunar eclipse from the UK, which you might have seen from the channel. A lunar eclipse occurs when the moon moves into the Earth's shadow, either fully or partially. While parts of Europe, the Americas, Russia and Africa will see a total lunar eclipse on this day, from the UK we'll see a partial lunar eclipse, where not all of the moon will be in shadow. During this particular eclipse, almost all of the moon will be in the Earth's umbra, the darker part of its shadow. The moon will first move into Earth's penumbra, the lighter part of its shadow, at 3:57 a.m. The maximum of the eclipse in London will be at 6:19 a.m, because during the eclipse's actual maximum at 6:58, the moon will have set below the horizon. Getting to our high point with a clear western view will allow you to see more of this eclipse. Though, due to its unsociable timing, we forgive you for sleeping through this one. On March 20th, the vernal spring equinox. Changes in the length of day and night are caused by the tilt of the Earth. When the Earth orbits the Sun at certain times of the year, the northern hemisphere is tilted towards the Sun, and the southern hemisphere is tilted away from it. For the other half of the year, the reverse happens. Equinoxes happen when neither hemisphere is tilted towards or away from the Sun, and there are roughly equal hours of daylight and darkness. Solstices, on the other hand, happen when a specific hemisphere is tilted towards or away from the Sun, which results in long days or long nights. The vernal or spring equinox will occur on March 20th in the northern hemisphere, and this is when astronomical spring is set to start. On March 23rd, Saturn's rings disappear. Saturn gets its nickname from the jewel of the solar system, thanks to its magnificent system of rings. On March 23rd, however, the iconic rings are set to disappear. This is due to Earth's orbit crossing the plane of the rings, a rare event that occurs about once every 15 years. In other words, the flat disk of the rings will be edge-on our perspective. Galileo was the first to notice the rings disappear from viewing a plane crossing in 1612. At the time, it was proposed that the rings were in fact moons of Saturn, leading Galileo to wonder whether Saturn swallowed his children. Subsequently, plane crossings have been very useful to astronomers in revealing Saturn's secrets. Things would have otherwise be obscured and be spotted when the rings are edge-on. Several of Saturn's moons have been discovered this way. On March 23rd, Saturn will be very close to the Sun in the sky, meaning we sadly won't be able to see the planet during the plane crossing. Despite this, it's pretty cool to know that our planet will be perfectly aligned with the iconic rings of Saturn. On March 29th, partial eclipse, solar eclipse. Rounding out March is a partial solar eclipse, where about 30 to 40% of the Sun will be obscured by the Moon at maximum. The partial eclipse will begin at 10:07 a.m. in GMT in London, when the Moon first touches the edge of the Sun. Maximum coverage is when the most of the Sun is obscured at 11:03 a.m. Then the Moon will gradually move off to the solar surface until the eclipse ends at 12 p.m. Here at the Royal Observatory we'll be live streaming eclipse, which you can look on the web or YouTube. Now we move into April, which is our final one, and only one in April. Lyrid meteor shower. In 2025, the Lyrid meteor shower will be visible from the 16th to the 25th of April, peaking on April 22nd. Though it's far from one of the most active yearly meteor showers, the Lyrids can still dazzle. Some meteors have bright dust tails that glow in the sky for several seconds. What's more, on the peak of the night of the 22nd and the morning of the 23rd of April, the moon will be below the horizon until 4 a.m. British summertime, so won't cause light pollution, making conditions ideal to observe the peak. The Lyrids are caused by debris from Comet C/1861 G1 Thatcher, which does a lap of the Sun once every 415 years. It's the oldest recorded meteor shower still visible today, and was first recorded in 687 BCE. Time for part 2.